This is Unit 2, Lesson 7, example number 2. So if we are given AB is parallel to CD and transversal EF, we want to prove that angle 1 is congruent to angle 5, and this will be proving corresponding angles theorem. If two parallel lines are intersected by a transversal, then the corresponding angles are congruent. So they give us that AB is parallel to CD, so I'm going to annotate that on my diagram. And I'm going to get my two columns set up. So remember, we can't just come out and say that angle 1 is congruent to angle 5. We need to show that. Alright, how are we going to do that? Well, we start with the given information. So AB is parallel to CD and transversal EF. How do we know that it's given? Okay, what can we say next? We can see that angle 1 and angle 3 are vertical angles. Definition of vertical angles. And we know that a property of that is that they're congruent. Angle 1 is congruent to angle 3. Vertical angles are congruent to one another. To each other. Again, that is a package that comes together. Those two statements and reasons come together when we talk about vertical angles, as we discussed in lesson number 6 today. Okay, well, next thing I can say is that angle 3 and angle 5 are alternate interior angles. And that's what they're defined to be. They're defined to be as two angles inside of two lines on opposite sides of a transversal. So definition of alternate interior angles. We can then say that angle 5 and angle 3 are congruent. And we can state alternate interior angle theorem, or we can write the long statement when two lines, parallel lines rather, are cut by a transversal. The alternate interior angles formed are congruent. Okay, well, I have shown that angle 1 is congruent to angle 3. Angle 3 is congruent to angle 5. Oops. So my final statement is what I'm trying to prove. Angle 1 is congruent to angle 5, and this is by the transitive property. And that is all for this example.